Okay, hey guys. So what we're doing here is implicit differentiation again here. So we're given a function, it's got x's and y's, and instead of actually just simply asking for dy dx, they actually ask you to evaluate this at a specific point. So they actually want to know the slope of the tangent line at x equals 0. And then they kindly give you the -1 here. And note, if they didn't give you the -1, you would plug a 0 in for x here and here, and you would end up discovering that y is equal to a -1 at that point. Okay. Um, is that right? And yes, -1, and you take the plus or minus 1. It'd be a plus or minus 1. So actually, there are two possibilities for that one. So there's a one with plus mine and one for minus 1. Whatever the case, in order to take this derivative here, what you're going to want to do is differentiate, obviously, both sides with respect to x. The derivative distributes in. And then here we've got, again, a chain rule. So dx of xy squared is this thing. I said chain rule, I meant product rule. So x differentiated to 1 and y squared stays. Then I add x not differentiated, and then I differentiate y squared, which is 2y dy dx. Remembering that this is a chain rule here. So a lot of students forget this dy dx and just write it 2y here. Remember, you're differentiating with respect to x. Y is a function with respect to x. And so you would have an entire new thing here, derivative here, that you just write down. Now, minus the derivative of 2x is simply 2. Same thing here. This is the derivative of y to the fourth, so it's 4y to the third. You also do the chain rule here for the same reasoning that we did the chain rule over here. And then d dx of 1 is just simply 0 because the rate of change of 1 with respect to x is 0 because 1 is always 1. Now, over here, now what you would do under some circumstances, you would solve for dy dx. But since they gave us the point, and they're really nice points too, zeros and ones, I'm actually going to plug everything in early on this one because it's just going to help out. Because look, this entire term goes away because there's a 0 right there. And then I've got a -1 in this side, but a -1 squared, so that becomes a 1. The 2 stays. This -1 to the third becomes a -4, and there it is. So I've got this. 1 minus 2 is a -1, and then my 1/4, my -1, whoops, I forgot a negative sign here. My -4 divides over, and I actually end up with a -1 over -4, and that is my derivative. Okay, now you don't want to just write dy dx because that's not the entire derivative. This is the derivative evaluated, so that's what that line means, evaluated at 0, 1. So remember, if you're like on the AP exam and you just write dy dx equals 1/4, they should probably count off on that because really that's a bad notation. And so what you want to do is remember that you've actually evaluated that. And so that's what this little line thing means here. Okay, so there's that one.